A $5 million German engine sat completely motionless in the heart of the largest energy facility in the Northeast. 3 days, 7 engineers from MIT, dozens of diagnostic reports thick with technical language. And the only conclusion they reached was this: it simply cannot be fixed. Every single hour the machine stayed idle cost $12,000. Diana Caldwell, a CEO cold as polished steel, watched the finest minds in America pack their equipment and leave. Then a man in an oil-stained uniform, holding handwritten German technical drawings, stepped out of the shadows and said, "Give me one night." What was truly hiding behind Isaac Mercer's work uniform? The truth would leave Diana Caldwell with nowhere left to stand. The alarm triggered at 3:17 in the morning, and by 3:22, Isaac Mercer was already standing inside the main turbine chamber of the Caldwell Energy Systems facility in New Hampshire, his hand pressed flat against the cold outer casing of the Lever G9512. The machine was silent, not the silence of a machine shut down for maintenance or scheduled rest. This was the silence of something that had simply stopped, without warning, without ceremony, without a single error code that made sense. There had been no explosion, no smoke, no vibration preceding the failure. One moment the engine had been running at full load, and the next it was gone, as if something deep inside it had simply decided enough. The red emergency lights along the corridor outside pulsed slowly, painting everything in the color of a problem no one had prepared for. The Liebherr G9512 was not an ordinary piece of equipment. It had been custom-built in Stuttgart at a cost of $5.1 million, engineered specifically for the Caldwell facility's load profile, and it served as the primary driver of the entire Eastern Generation chain. Without it, the facility ran on backup systems at 60% capacity. Every hour of downtime translated to $12,000 in direct contract losses, plus SLA penalty charges owed to 3 state-level utility partners whose grids depended on Caldwell's output. The math was not difficult, and it was not kind. Isaac walked slowly around the perimeter of the engine, taking nothing out of his bag yet. He did what he always did first. He listened. He stood still for nearly a minute with his eyes closed, one hand resting lightly on the machine's outer casing, the way a doctor might place a hand on a patient before reaching for any instrument. Then he opened his eyes, unclipped the small tablet from his belt, pulled up the internal technical schematics, and cross-referenced something against a handwritten note in the small, leather notebook he kept in the left breast pocket of his uniform. He wrote 3 short lines in German. Connor Wade, the night shift floor manager, jogged into the chamber just then, his boots loud on the concrete. He was a thick-shouldered man who dealt well with most crises and poorly with ones he could not categorize. "Isaac," he said, slightly out of breath, "what are you seeing?" Isaac looked up from his notebook. "I see something," he said. "I need to confirm one more thing before I can say it clearly." Connor paused, then, "It doesn't matter. I already called upstairs. Mrs. Caldwell was notified 20 minutes ago. She's pulling in a specialist team from MIT. They arrive tomorrow morning." Isaac went still for a half-second. Then he nodded very slowly and slid the notebook back into his pocket. "Understood," he said. "Do you want me to keep the area cleared for them?" Connor nodded. "Just make sure the log data is accessible and the chamber is clean. They'll handle the rest." Isaac said nothing more. He looked back at the machine one more time, at the particular section just behind the primary fuel return line, where a small access panel no larger than a kitchen cabinet door sat flush with the casing. He looked at it the way a person looks at something they already know the answer to. Then he turned and walked out, and the red lights continued their slow, indifferent pulse behind him. He did not tell Connor what he had already seen, not because he was holding something back out of pride, but because he understood with the precision of someone who had spent years inside institutions of technical authority that there was a specific kind of room in which a man in a night shift uniform was not heard. Tonight was not the time. The time would come, but it would have to be earned, and it would have to be earned on someone else's terms before it could be his. Isaac Mercer had worked at the Caldwell Energy facility for 4 years. The file on record in the Human Resource Department described him this way: 38 years old, bachelor's degree in mechanical engineering from the University of Vermont, 4 years of prior industrial maintenance work in the Mid-Atlantic region, no citations, no complaints, no awards. It was a file that no one read twice. There was nothing in it that demanded a second reading. What the file did not contain was the other version of Isaac Mercer's life, the one that existed in German academic journals, in patent filings registered with the Deutsche Patent- und Markenamt, and in the internal engineering archives of Liebherr International AG in Stuttgart. For 6 years, from 2012 to 2018, Isaac had served as the lead engineer of the Engine Research and Development Division at Liebherr. He was one of the very few Americans in the company's history to hold that role, and he held it during the years when Liebherr developed its G9000 series, the most advanced industrial gas turbine line the company had ever produced. Isaac did not just work on the G9512, he co-designed it. The primary pressure distribution architecture, the two-stage combustion regulation system, the sealing specifications for the high-temperature fuel pathway, all of it bore, in some form, his fingerprints. He knew the machine the way a person knows the house they built with their own hands. He had left Liebherr in the spring of 2019, not because of a conflict or a failed project or a better offer. He had left because his wife, Catherine, had died in February of that year, a road accident outside Heidelberg on a Tuesday morning. When the roads were still iced and the light was bad, they had a daughter. Giselle was 5 years old and she had her mother's eyes, and Isaac had flown home to New Hampshire with her and not gone back. He had chosen a job that required no travel, no conferences, no extended project cycles in foreign cities. He had chosen a job that let him be home every night. He understood exactly what he was trading, and he made the trade without hesitation, and he had never once described this as a sacrifice to anyone who asked. He had not listed his Liebherr experience on his application to Caldwell Energy Systems. This was deliberate, made for 2 reasons he never articulated, but both of which were real. The first was that a CV like his would have placed him in a category of person who gets recruited into consulting roles and cross-facility projects requiring extended absences, exactly what he did not want. The second was simpler. He had no interest in being the most impressive person in any room. He had spent years in rooms where that was expected of him, and he knew what those rooms cost. His night shift colleagues at Caldwell liked him because he was steady, because he never left a problem half-solved, because he could find the fault in a hydraulic system at 2 in the morning with the same unhurried attention he brought to everything. None of them knew where that steadiness came from. On the evening before the MIT team arrived, Isaac sat alone in the locker room with his notebook open on his knee, drawing from memory a full schematic of the G9512's pressure distribution system. Nobody had asked him to. He simply could not sleep while knowing the answer and saying nothing. Diana Caldwell arrived at the facility at 7:15 the next morning in a charcoal suit that had not been chosen casually. She was 44 years old, and she carried authority the way certain buildings carry weight, structurally, without effort, without announcement. She did not stop at the reception desk. She did not acknowledge the maintenance crew in the corridor. She walked directly to the operations center, pulled up the downtime logs on the main display, and stood there for 90 seconds reading numbers. Then she turned to her assistant and said, "When does the MIT team get here?" The answer was 30 minutes. She nodded once and turned back to the screen. Lucas Hartfield led the team through the facility entrance at 7:47, and he led it the way a man leads a room he already believes belongs to him. He was 41 years old, a tenured professor of industrial power systems at MIT, a published authority on large-scale turbine failure diagnosis, and a consultant whose day rate was not publicly listed because it was the kind of number that required a prior relationship before it could be spoken aloud. He had 6 engineers with him, including Xavier Monroe, who was quieter than the others and noticed things differently. Connor Wade met them at the chamber entrance and went through the standard briefing: machine specs, downtime duration, backup load status. Lucas listened with his arms folded and his chin slightly raised. When Connor finished, Lucas scanned the room once, then looked past Connor's shoulder to where Isaac Mercer was standing near the far wall, clipboard in hand. "Who's the maintenance lead?" Lucas asked. Connor said, "That's Isaac. He's our night shift technician. He was on site when the shutdown happened." Lucas looked at Isaac for approximately 1 second. Then he looked back at Connor. "We'll need unobstructed access to the chamber and full access to the diagnostic logs going back 60 days. Your team stays clear of the engine while we work. We'll let you know if we need anything." He did not address Isaac directly. Isaac said nothing. He stood near the door for a moment longer, then nodded once to Connor and walked out. In the corridor, he stopped at the water fountain, took a slow drink, and stood there for a few seconds with his hand resting on the wall. Xavier Monroe came through the door behind him, moving quickly, head already down, reviewing a tablet, and nearly walked past before he registered Isaac standing there. Monroe glanced sideways at the small leather notebook sticking out of Isaac's breast pocket. The notebook was open, and Monroe caught a fraction of a second of the handwriting inside. Dense technical notation, clearly not English, clearly not copied from a standard reference document. He said nothing. He kept walking, but he slowed down just slightly before he turned the corner. Back in the chamber, the MIT team deployed their diagnostic suite with the efficiency of people who had done this many times before. Their equipment included a real-time multi-axis vibration analyzer, a thermal imaging array, a pressure differential monitoring system linked to 3 external sensors, and a proprietary data interpretation platform that had cost $230,000 to develop. It was, by any reasonable standard, the best diagnostic toolset that existed for this class of machine. They ran an initial passive scan. They reviewed 60 days of log data. Lucas stood at the central display and began building his diagnostic tree, methodically eliminating possibilities from the outside in. There was nothing wrong with the methodology. It was rigorous and thorough, and exactly what the situation called for. The only thing it could not account for was information that did not exist in the English language documentation Lucas was working from. But that was not a problem Lucas knew he had yet. By 10 in the morning, Diana had approved the team's first full access request, and they were deep into the machine. Isaac, by that point, had been asked to bring coffee to the engineering team. He had done so without a word. Connor had apologized with his eyes. Isaac had answered with a small nod that said, "It's fine." He set the tray down, and as he turned to go, his eye passed over one of the printouts on the work table, a column of pressure differential values from the overnight logs. He read it in less than 2 seconds. His expression did not change, but the corner of his mouth moved, barely, almost nothing, in a way that was not quite a smile. It was closer to recognition. By mid-afternoon of the first day, Lucas Hartfield had a working theory. The diagnostic data pointed, in his assessment, toward a fault in the tertiary solenoid valve cluster, electronically controlled valves that regulated fuel flow at medium pressure. He presented this assessment to Diana with the measured confidence of a man presenting a conclusion he considered settled. Diana approved the repair order. The valve assembly was sourced from the facility's on-site inventory and replaced at a parts cost of $47,000. At 4:40, the team ran a restart sequence. The engine came to life. It ran for 8 minutes and 12 seconds, then it stopped. The same way, no error code, no vibration signature, no thermal spike, it simply stopped. Lucas did not lose his composure visibly, but Xavier Monroe watched him absorb that moment and registered something shift behind his eyes. Lucas turned to the display and said quietly, to Monroe, "It's not the valve cluster, we're dealing with something deeper. Possibly the high-pressure fuel flow control block." Monroe nodded. He said nothing else. But later that evening, while the team reviewed data in the facility's temporary workspace, Monroe sat apart from the others, and he kept thinking about the handwriting in that notebook. He had worked with enough engineers in enough countries to recognize technical notation when he saw it, even for a fraction of a second, and what he had seen in Isaac's pocket had not looked like the shorthand of a maintenance technician reviewing service manuals. It had looked like the work of someone who had designed something. He did not say this to Lucas. Isaac came through the conference room that evening to replace the paper in the printer near the door. The team was in mid-discussion. Nobody acknowledged him. He worked quietly and was on his way out when something on the whiteboard made him slow. A diagram Lucas had drawn of the engine's internal pressure pathway, with 2 sections circled in red as probable fault zones. Isaac looked at it for 3 seconds. Then he walked out. In the cafeteria, he sat alone at the corner table with a sandwich in his notebook. Connor sat down across from him. "Isaac, do you know what's wrong with it?" Isaac looked up. "Yes." Connor stared. "Then why haven't you said anything?" Isaac said, "Because no one has asked me. And because if I walk into that room right now, the first thing that happens is I get asked who I am and what my credentials are. They need to rule out what they think it is before they can hear what it actually is." Connor opened his mouth, closed it, and let out a long breath. He had no answer for that because he knew Isaac was right. The second day was longer and harder. Lucas made the decision to pull the primary pressure regulation assembly, a 12-hour process requiring 4 technicians and a full mechanical teardown of one side of the engine housing. Isaac was called in to assist as an extra pair of hands, passing tools, holding panels, running torque sequences. It was during this process that Isaac confirmed, with absolute certainty, what he had suspected from the first night. He reached inside the access cavity during one of the disassembly stages, his fingers finding a small internal component no larger than a clenched fist, and he knew exactly what he was touching. He said nothing. He handed a wrench to the engineer beside him and continued working. By end of day 2, the pressure regulation assembly had been examined and cleared of any fault. removed, inspected, and reinstalled at the cost of 11 hours of labor, and the pride of every person in that room. The MIT team had now spent 44 of their 48 billable hours on a machine that remained broken. Lucas Hartfield called a formal review meeting at 6 in the evening. Diana Caldwell sat at the head of the conference table. The MIT team occupied one side. Connor Wade stood near the back wall. Isaac was not in the room. He was in the corridor, visible through the glass panel in the door, leaning against the wall with his arms folded. Lucas presented his findings with the structured precision of a man who had delivered difficult conclusions before and had learned to package them in language that preserved the authority of the person delivering them. He said the team had performed an exhaustive diagnostic evaluation and had eliminated every mechanically addressable fault within the scope of on-site intervention. He said the data indicated an internal combustion stage failure at the secondary pressure regulation tier, consistent with long-term thermal accumulation at the manufacturing level. He recommended contacting Liebherr International in Germany, decommissioning the engine, and transporting it overseas for factory-level assessment. Timeline: 8 to 12 weeks. Estimated additional cost: between $300,000 and $800,000. He said this was his team's final recommendation. The room was quiet. Then the door opened. Connor said, "Mrs. Caldwell, I'm sorry, but Isaac, our night shift technician, he's been here since this started. He's asked if he could say something." Lucas turned his head toward the door the way a person turns toward an interruption they have already decided is beneath them. Diana looked past Lucas through the doorway to where Isaac Mercer stood in the corridor in his work uniform, his notebook in one hand. "Who are you?" she said. Isaac stepped into the room. "Isaac Mercer, night shift maintenance technician, 4 years here." A pause. "What do you want to say?" Isaac said. "I'd like to ask for one night, 10 o'clock tonight to 6 o'clock tomorrow morning. I'll fix it." The silence that followed had a particular texture. Lucas broke it first. His voice was controlled, but only the way a pressurized line is controlled, by something narrow that could give at any moment. "Listen," he said. "My team has spent 48 hours on this machine with the best diagnostic equipment this industry has. You don't have that equipment. You don't have credentialing in industrial turbine systems. What exactly do you believe you can do in one night that 7 MIT engineers could not do in 2 days?" Isaac turned his head and looked at Lucas directly. He took a moment, and the moment was not hesitation, it was the opposite. "That question," he said, "is not addressed to the person who owns this machine. You're not paying for it." Lucas went very still. The room held its breath. Xavier Monroe, standing at the far end of the table, looked down at his hands. Diana studied Isaac for a long moment. She was calculating, not trust. She was not built for impulsive trust, but risk. She had already lost 3 days and more than $150,000. The machine was not fixed. "If you damage it further," she said, "you carry full personal liability for any additional repair costs." Isaac said, "Agreed." She said, "You have 8 hours. I want to be here at 6 in the morning." Isaac said, "Yes." He turned and walked out. Lucas said to Xavier, not bothering to lower his voice, 9 hours from now, we're going to be managing a machine that a wrench jockey made worse." Xavier did not answer. He was watching Isaac walk down the corridor, not fast, not slow, not performing anything for anyone, and there was something in that walk that made Xavier Monroe feel he had missed something important, and that he had missed it more than once. Isaac entered the turbine chamber at exactly 10 o'clock and locked the door behind him. He turned off the fluorescent overhead panels and switched on the single high-intensity work lamp he had positioned earlier that day, angling it directly at the access panel behind the primary fuel return line. Then he opened the equipment bag he had retrieved from his personal storage locker. Not the facility's standard maintenance kit, but his own, the one that had traveled with him from Stuttgart and had lived at the back of his locker since his first week at Caldwell. A Hazet torque driver set. A Weka differential pressure gauge calibrated to microbar precision. An Olympus industrial endoscope with a 7mm flexible probe. Tools that were not on the Caldwell Energy asset inventory. Tools chosen for a specific class of work on a specific class of machine years before this machine had ever arrived in New Hampshire. He did not start where the MIT team had started. He went directly to the primary fuel feed line, a secondary diameter conduit running along the back wall of the combustion housing, tucked behind the main cooling assembly, positioned outside the priority zone of any automated diagnostic system. The MIT team had not touched this section. There was no particular reason they would have. Nothing in the English language technical documentation flagged it as a probable fault location. Isaac removed a small inspection cover adjacent to the fuel return valve, inserted the endoscope probe, and directed it toward the internal seal housing of the secondary pressure pathway. He watched the display screen as the image resolved, and he saw exactly what he had known he would see since the first night. The problem was a high-temperature composite sealing ring, a component specific to the G9000 series, manufactured to Lever's internal specifications using a proprietary synthetic material that appeared in no standard parts catalog under any commercial name. In the English-language documentation supplied by Lever's American distribution partner, this component was not listed individually. It existed only in the internal German-language maintenance records under its factory designation, Dichtungsring G9V2 HT Composite. Isaac knew that code because he had been in the room in Stuttgart in 2016 when the materials engineer had presented the compound data, and Isaac had argued successfully for using it in the G9512's fuel pathway. The ring had deformed, not catastrophically. The dimensional deviation was 0.3 millimeters, less than the thickness of 3 human hairs, but that deviation was enough. At cold operating temperatures, the seal held. As the engine warmed through its first 8 to 12 minutes of operation, thermal expansion pushed the pressure differential in the secondary fuel pathway beyond the threshold at which the engine's automatic protection system cut the ignition. No error code generated, no mechanical signal visible from the exterior, nothing that any diagnostic system could detect without knowing exactly where to look and what it was looking for. The MIT team had been working from the wrong map. Isaac withdrew the endoscope, sat on an overturned equipment crate, and took 30 seconds to think through every remaining step. Then he picked up his phone and dialed a number he had not called in 2 years. The contact in his phone was listed as a single letter. H. The phone rang 3 times. A German voice answered, thick with the late hour. Isaac switched immediately into German, speaking quietly and quickly. The call lasted 4 minutes. When he hung up, he had an address written in his notebook. He drove 14 miles through the dark to a technical parts warehouse, run by a retired German machinist who maintained a private inventory of European industrial components for the region's manufacturing sector, and who answered his phone at midnight without complaint because that was the nature of the work. Isaac found the correct component in drawer 17. 3 units remained in stock. He bought 2, paid cash, and was back at the facility by 1:30 in the morning. The installation required precision and patience in equal measure. The access space was narrow, the tolerances were exacting, and the work could not be rushed. Isaac did not rush it. He worked in silence in the pool of white light from the work lamp with a steadiness of hand that comes not from calmness but from certainty. Connor Wade appeared in the doorway at 2 in the morning, unable to sleep. He stood watching for several minutes without speaking. What he saw was a man who was not simply fixing a machine but returning something to the condition it had been designed for, with the confidence of someone who had defined that condition himself. Connor said nothing. He sat down on the floor near the door and stayed. At 3:15, Isaac set down his tools and ran his hands over every connection point one final time. He clamped the Weka pressure gauge to the test valve on the fuel return line. The numbers fell within the design range exactly. He unclamped the gauge and put it away. He drank half a bottle of water and looked at the clock. At 3:45, he pressed the engine restart switch. The Lever G9512 turned over and woke up. Isaac stood and listened. 1 minute, 2, 5, 8 minutes and 12 seconds, the point at which it had died on every previous attempt. The engine did not stop. The pressure held. The sound of it in that room at that hour was the deepest sound Isaac had heard in a long time, low and even and absolutely certain of itself. He sat down against the wall, his back straight, his eyes closed. Nobody was there to see that, only the machine still running. Diana Caldwell arrived at 5:45. She had simply not slept, and at some point before 5 in the morning she had stopped pretending she was going to and driven to the facility instead. She walked through the main entrance and turned down the corridor toward the turbine chamber. Before she rounded the final corner, she stopped. She could hear something. She stood very still for a moment with her hand on the wall. She was hearing the engine. Then she walked faster. Isaac was standing near the main control panel when she entered, reviewing the operational data on the display screen. The clock on the wall read 5:47. He turned when he heard her footsteps. "It's been running for 4 hours and 12 minutes, he said. "All parameters are within the manufacturer's design tolerances." Diana moved to the screen and looked at the numbers: pressure, temperature, fuel flow rate, combustion cycle frequency, and they were all exactly where they needed to be. She looked at the display for a long time. Then she looked at Isaac. Her voice when she spoke was carefully level. "How did you do it?" Isaac reached into his breast pocket and took out the leather notebook. He opened it to the relevant pages and placed it on the workbench between them. The pages were covered in dense handwritten analysis, system diagrams, component codes, pressure calculations, all of it in German. Diana looked down at the pages. Her German was functional rather than fluent, but it was sufficient to tell her one significant thing. This was not copied from a reference document. This was original work, written by hand. "What seal?" she said, her voice dropping slightly. Isaac pointed to the component code at the top of the page. She looked at it. "That code isn't in our technical documentation," Isaac said. "No, because your documentation is the English language summary version distributed by Lever's American reseller. This code only exists in Lever's internal German language maintenance records." A pause. "How do you know it?" Isaac held her gaze. "I know it." He offered no more than that. Diana studied him the way she studied balance sheets and people who were hiding something she needed to find. She could see the shape of what she was not being told. She could not yet see the content. Lucas Hartfield arrived at 6:10. He walked in, looked at the operational display, looked at Isaac, and then looked at Diana. He stood there for 15 seconds without speaking. Then he said, his voice stripped of everything except the question itself. "What did you do to it?" Isaac handed him the notebook. Lucas began to read. The change that moved across his face was slow and went deep, the way a temperature change moves through a large body of water, beginning at the surface and working down. Xavier Monroe had followed Lucas in and read over his shoulder, and his face changed faster. It was Xavier who spoke first, quietly. "Dichtungsring G9V2. That's Lever's second-generation composite compound. We don't have documentation on this because..." Lucas placed a hand on Xavier's arm. Xavier stopped, but he looked at Isaac directly, and what he said next was not phrased as a question. "You worked at Lever." Isaac did not confirm it. He did not deny it. He looked at Diana and said, "I'd like to check the system again at noon if that's possible. I want to verify the seal is holding at full operational temperature," Diana said. And something in her voice, some calibration of it, was not what it had been the day before. Xavier Monroe did not sleep that morning. He went back to the temporary workspace, sat down at his laptop, and started looking for Isaac Mercer. This was not something Lucas had asked him to do. It was something Xavier could not stop himself from doing, the way certain puzzles refuse to release the mind once a piece has shifted into place. He searched the specialized engineering journal databases, the ones requiring institutional login credentials not visible to public search. The first result came back in less than a minute. A paper from 2015, published in the Journal of Industrial Turbine Engineering through Stuttgart University of Technology, on the subject of multi-stage pressure distribution in high-capacity industrial combustion engines. 2 authors. The first was a senior Lever research director whose name Xavier recognized. The second was listed as I. Mercer, R&D Division, Lever International AG. Xavier kept searching. He found 3 more papers in the same period, all in German language engineering publications, all co-authored by the same I. Mercer with a Lever affiliation. Then he found the patents, 3 of them, registered jointly between 2014 and 2018, filed simultaneously with the German Patent and Trademark Office and the United States Patent and Trademark Office. Isaac's name appeared on all 3 as a co-inventor. The third patent described, in technical detail, the pressure regulation architecture of the G9000 series. Within the patent document, in a section on materials specifications for the secondary fuel pathway sealing system, was a paragraph written in Isaac's technical voice, the voice of a man who had argued for a specific compound on specific grounds and had documented every part of that argument. The paragraph concluded with a note on the material's operational lifetime limit under thermal cycling conditions, the exact conditions that, after years of accumulation, had produced the failure inside the Caldwell facility. Xavier sat with this for a while. Then he printed everything and walked directly to Diana's office. Diana read the documents without speaking, turning each page with deliberate care. When she reached the patents and saw Isaac's name alongside the Lever affiliation, she held that page and did not turn it for a long time. Then she set it down and said very quietly, in a voice that had not yet decided what to do with itself, "He designed this engine." It was not a question. Xavier said, "Co-designed." "And the seal he replaced last night, the compound, that specific formulation, he's the one who proposed using it in the G9512. The thermal degradation parameters he described in the patent document from 2016 are exactly what caused the failure. He wrote the failure mode into the documentation 8 years ago." Diana said nothing. She called Lucas into her office and placed the documents on the desk without a word. Lucas read. He was a man who had spent his career being the most knowledgeable person in difficult rooms, and he sat there now reading the record of knowledge he had not known existed, and there was nothing for his face to do that did not cost him something. Diana, when she finally spoke, made no effort to soften her words. $85,000 in consulting fees, she said. $47,000 in incorrectly replaced components. 3 days of downtime costs. Your team's conclusion was that this machine could not be fixed on site. The man in the work uniform did it in 8 hours. Lucas said, Mrs. Caldwell, she said, I don't need an explanation, I need a revised invoice from MIT by Friday. Connor Wade, who had been standing outside the half-open door, heard every word. He walked down to the locker room where Isaac was asleep on a bench with his jacket folded under his head. Connor stood there for a moment, then took off his own jacket and laid it gently over Isaac. He walked back out without making a sound. Isaac woke at 1:30 in the afternoon, checked the engine, running without deviation, all readings clean, and began collecting his tools. He was packing them methodically, each piece in its place, when Diana Caldwell walked into the turbine chamber alone. No assistant, no notepad. She closed the door behind her, and for a moment the two of them stood in the low continuous sound of the machine that one of them had built and the other had fixed. Diana came to stand a few feet in front of him and looked at him directly, the way she looked at things when she had decided to stop managing a situation and simply meet it. I want to ask you a direct question, she said. Why didn't you say something from the beginning? Isaac placed a wrench into the bag before he answered. Because you didn't ask, he said. You called MIT. Diana said, I didn't know who you were. Isaac said, you didn't ask that either. There was no grievance in his voice. He was not offering her a wound to apologize for. He was simply placing the sequence of events in front of her with the same accuracy he brought to everything else. The weight of that settled on Diana in a way that surprised her. She was not a woman who was frequently surprised by her own reactions. Why didn't you list your background when you applied here, she asked. Isaac said, because I didn't want a job based on a CV. I wanted a job that let me go home at the same time every night. She looked at him for a moment with something that was not pity and was not admiration, but was the specific attention of a person encountering something they had not previously accounted for in their model of how people work. She looked at his hands, at the small cuts from the work of the night before, at the oil still under his fingernails. Then she looked up. I owe you an apology, she said. Isaac shook his head. You don't owe me anything. I did my job. Diana said, I had you serve coffee to people who were not as capable as you. Isaac stopped what he was doing. He looked at her. For the first time across all of this, 3 days of silence and 1 night of work, something shifted in the way he regarded Diana Caldwell. He had looked at her before as he looked at most people, present, observant, without particular feeling. Now he looked at her like a person who had said a true thing and knew it, without needing to be told. Do you want to know what the real problem was? He said. Diana waited. Lucas was not wrong because he lacked intelligence. He was wrong because he assumed the complete answer existed in the English documentation. Nobody told him there was a German version. Nobody here knew there was a German version. Diana said, and you knew that from the first night. Isaac said, yes. A pause, but you would not have believed me then. She was still for a moment. Then she said quietly, no. I wouldn't have. And the fact that she said it plainly, without hedging, without redirecting, that told him something. The engine ran steadily between them. Diana looked at the machine, then back at the man. Is there anything you want, she said. Not as a transaction, just as a real question. Isaac picked up his bag. My night shift position is fine, he said. She looked at him steadily. I'm not talking about your pay grade. He met her eyes. Neither am I. A silence that was not uncomfortable passed between them. Then Diana turned to leave. At the door she stopped without turning back. I'm going to send you a technical consulting agreement this evening. She said it's not mandatory. But the next time something like this happens, I want you to be the first person I call. She walked out. Isaac watched the door close. He did not say yes, but he did not say no, and in the particular language of people who mean what they don't say, that was already an answer. By 4 o'clock that afternoon, the Caldwell Energy facility had returned to full operational capacity. The 3 state utility partners received confirmation that output had been restored and no further SLA penalties would accrue. The backup systems were taken offline in sequence, and the main turbine chain resumed its steady load-bearing work as if nothing had ever happened to it. Lucas Hartfield and the MIT team had left at 3 o'clock. Xavier Monroe was the last of them to walk out. He paused in the corridor where Isaac was standing near the equipment room, closing his bag. Monroe extended his hand, he said, for our part in all of it. Isaac shook his hand. Don't be, he said. You followed your process correctly. Monroe looked at him. Our process has a gap in it. Isaac nodded. Yes, he said, it does. That was the end of that conversation, and both of them knew it was enough. Connor Wade found Isaac near the end of the afternoon shift, leaning against his truck in the parking lot. You should have told me, Connor said. I asked you directly. Isaac said, could you have changed Mrs. Caldwell's decision? Connor was quiet. No, he admitted. Then there was nothing to tell you that would have helped, Isaac said. But what you did in that meeting room, introducing me the way you did, that was the thing that mattered. That was the door. Connor looked at the ground and then back up. You knew I was going to do that? Isaac said, I thought you might. You're a decent man, Connor. Connor laughed once, short and slightly baffled, and then went back inside. Isaac sat in his truck for a while before starting the engine. He took the folded paper from his bag, the one with the parts warehouse address written the night before, looked at it for a moment, folded it carefully, and put it in his wallet. These were the things worth keeping, not as memories, as materials, because the world had a way of producing another machine that needed what only certain knowledge could provide, and it was better to be ready. At 7:32 in the evening, Diana's email arrived. The subject line was, Technical Consultant Agreement, Draft Version 1. No preamble, no pleasantries, just the attachment and a single line. Read when you have time. No response needed tonight. Isaac opened the document and read it in the parking lot of a gas station 2 miles from his house. The consulting rate Diana had set for him was $850 per hour. She had not negotiated it with him. She had simply decided what it was. He set the phone on the passenger seat and looked out through the windshield for a while. The New Hampshire sky in November went dark early, and it was already full dark by 7:30. He thought briefly of Stuttgart, of the first time he had stood behind the observation glass watching the G9512 fire up in the test facility. Himself at 31, surrounded by engineers who had spent years on that machine. The sound had been exactly the same then as it was tonight. Some things did not change. He drove home. Giselle was already asleep. He went quietly through the house, looked in on her through the cracked door, pulled it closed, and went to the kitchen. He made coffee, sat at the table, opened the notebook to a blank page, and picked up his pen. Outside, the November dark was total and still, and in a facility 14 miles away, a machine he had helped to build continued to run, in the quiet way of something restored to what it had always been, by a man nobody had thought to ask. Nobody, that is, until now.